Literal equations. In this video, we'll be tackling how to solve something called literal equations. So first, let's define what that is. All a literal equation is an equation with more than one variable. So more than one variable. With that out of the way, at this point, we should feel very competent solving linear equations. In many situations, we might even solve equations where there are no numbers given. But do not let the letters overwhelm you. We are still applying the ideas that we have been using over the last couple of sections. For example, you should be familiar with the formula for the area of a circle. A equals to pi r squared. In the form A equals to pi r squared, we say that A is the subject of the formula. So A is the subject. And the reason why we say A is the subject is that it's been solved for by its lonesome self. More formula, A is completely isolated. We notice that A is by itself and it equals some other stuff. Just like how in the previous problems, we were solving for x by getting x by itself, right? That last step, isolate x. So when it comes to solving for the subject of a formula, there's not too many steps. First, highlight the subject. And then once we have highlighted the subject, we can then write out the build steps using GEMDAS by describing what has happened to the subject. And then once we have the build steps, we can undo in reverse order. So let's go ahead and take a look at what that looks like. Exercise 1A. Y equals to 2x minus a, and we want to solve for x. Now this actually isn't any different from what we've been doing before. The only difference here is I'm going to highlight x because x is the subject. It's what I want to get by itself. And now that I highlighted, I can pay attention to it. What has happened to x? Well, using order of operations, first we have the 2, which is next to the x, and so the build order is first the x was multiplied by 2, and then secondly, the minus a means that it was subtracted a. So before we had all numbers. In this case, we have some letters, but it doesn't change how we do the problem. Right? Now that we have the build order, we will undo. So here's the original problem. And so first, we're going to undo the subtraction, and the way we do that is we add a. So I'm going to add a to both sides. Now again, don't let the letters confuse you. Y and A are completely different letters, so I can't combine them, so I simply leave it as y plus a equals to, on the right hand side, I have 2x, and then the a's will cancel each other out. Now that we've undone the subtraction by a, we need to undo the multiplication. So the opposite of multiplying is dividing, so I'll divide both sides by 2. And so on the left-hand side, I can't really do too much other than to leave it as it is. So y plus a all over 2 on the left-hand side. And on the right-hand side, 2 divided by 2 is 1. And so all we're left with is the x. And now notice that the x is completely by itself, and so we have successfully solved for x. Now in exercise 1b, it's going to be really similar. It's just we have more letters, but it's the same idea, right? We're solving for x, so I'll highlight x. Now there are 3 things that are happening in this problem. First, the a means that it has been multiplied by a. Then we have the minus y, which means that it has subtracted y. And then next we have the plus z, which means that it has been added z. And so if that's the build order, we now need to undo all of that in reverse order. So first, I'll copy down the problem. And so we need to undo the adding of z. And so I will subtract z from both sides, which gives me ax minus y is equal to b minus z. Again, these letters are completely different, so we can't really combine them. Now I need to undo the subtraction by y, and so I will add y to both sides. So this gives me on the left-hand side ax, and on the right-hand side we have b minus z plus y. Technically speaking, it doesn't matter what order we write the letters in, and so if your answer doesn't match mine exactly, it's okay, as long as we respect the signs. Now, lastly, we need to undo the multiplication, and so we'll undo the multiplication by dividing both sides by a. And so this means that my solution is x is equal to b minus z plus y all over a. So exercise 1, we were still solving for x, right? Because the previous videos we've been solving for x, and I wanted to leave it like that to kind of transition. But every problem doesn't necessarily have to solve for x. In fact, we'll go ahead and move on to exercise 2. And in exercise 2, we are asked to solve for the indicated variable. In 2a, we have 2s is equal to 2ut plus at squared, and then we are asked to solve for a. So our first step is to highlight the subject that we're asked to solve for. Okay, so now that I've highlighted a, let's go ahead and think about what's happening. We have a t squared that is attached to the a. Remember our invisible math. If you have letters or numbers next to each other with no sign, then it is assumed that there is multiplication. So what is the t squared doing since it's next to the a? Well, the t squared is multiplying. So we can do our build order, and using GEMDAS, this means that the t squared that is right next to it is done first. Multiply by t squared. What else do we have? Well, we have this 2ut. While it is true that technically there are 3 different things going on, since we are trying to get a by itself, for the purposes of this problem, we can kind of group the 2ut together. And so the 2ut, what a tongue twister. What is that doing? Well, consider the fact that there is an invisible positive sign in front of the TUT. And right, because if you don't see a negative sign, you can assume that a term is positive. And so since this is a positive 2UT, it is being added. And so that's the second step of the build order. The problem added TUT. And that's it. There's only 2 steps that in the build order, and so we are only going to need 2 steps in our unbuild order. So first, I'll write the original problem. 2s equals to 2ut plus a t squared. So what are we going to do first to unbuild? Well, just like before, we're going to undo in the reverse order. So since the problem last added, we are going to subtract. And so I will subtract the 2ut from both sides. And so on the left-hand side, because the variables are different, I cannot combine them. So it is simply 2s minus 2tu. And on the right-hand side, the two UT's will cancel each other out, leaving me with AT squared. And now that we've undone the addition, we need to undo the multiplication. So the opposite of multiplying is dividing. And what am I going to divide by? Well, whatever I see in that build step. So since it was multiplied by t squared, we are going to undo by dividing by t squared. And then this means that on the left-hand side, I have 2s minus 2tu all over t squared. And on the right-hand side, I simply have a. Now go ahead and try to do 2b on your own. Okay, so first step, highlight the subject of interest, which is S. And with that, we can then write out the build order. So think about what has happened to S. First of all, the 2 and the A right next to it means that the problem has been multiplied by 2A. And then that u squared, since there's no sign, it is assumed to be positive, and so it added u squared. Now we can undo this in reverse order, and so to unbuild, first we copy down the original problem, and then to unbuild, we first undo the subtraction, and so I will subtract u squared from both sides, which gives me v squared minus u squared equals, oh, I don't know why there's two equal signs looking right there, equals to 2as. And then we need to undo the multiplication, and so we'll divide both sides. And what are we going to divide by? Well, since it was multiplied by 2a, we'll divide by 2a. And so by doing that, on the left-hand side, we simply have v squared minus u squared all over 2a. And on the right-hand side, the 2a's will reduce each other, leaving me with 1s over 1, or simply s. And now we have s by itself, and that is this problem.